Hi everyone, my name is Alicia Seidle, and I am from the Open Source Hardware Association, and I wanted to tell you a little bit about the physical future of open source, or what I call a general talk for what is open source hardware. So my background is in library and information science, and as a librarian, I learned that access to information and freedom of information are really important. And that's actually what got me into the concept of open source, having access to information. My other background is in art history. And so I have also seen throughout the ages, artists will copy the greats and create derivatives like we've got here. This is Da Vinci and Duchamp, both more or less kind of pictures of the Mona Lisa, but one's a little different. See if you can figure it out. But I think what this has done for me is show me the value of creating derivatives, show me the value of copying people who you know how that they know how to do it and applying it to your own learnings and your own hardware. So as I mentioned, I am with the Open Source Hardware Association. We are a nonprofit. I am the executive director, and we are stewards of the community. So we host the definition, for example. We have a certification program. We've got places and spaces to talk, events, all kinds of fun things around open hardware. And you may notice that we used to look like this for our logo. And recently we just changed to this. It's very new and fancy and shiny. And we have a website to follow. Hopefully in 2024, we will have a brand new look and feel to our site. So we did not start open source hardware. We did not coin the term. There was lots of people that came before us as well. So open source hardware was first discussed in 1997. There was a certificate program then. There was also a license, one of the first open hardware licenses called Tapper. There was a group called OHWA that sort of applied a design trademark to open hardware. And then the community in 2010 created the open hardware definition, and that is the one that we host on the OSHWA website that you can endorse if you agree with the definition of open source hardware. We also started having events around this time. We ended up creating a communal logo that's that kind of gear shaped logo. We also, there started being more players in the licensing community. And then in 2012, OSHWA was formed, and a couple years later we got our nonprofit status. And ever since then we've been trying to do things that the community is asking for or that we have the capacity to do, and really just trying to help out people who are learning how to do open source hardware. We are here to welcome you in with open arms. So what defines open source hardware? Here's the definition. As I mentioned, it's on our site. And if this is a little small to read and a little long, too long didn't read version, is open source hardware allows people to remix, remake, remanufacture, redistribute, resell, and study and learn from your hardware that is open source. So what is the source? This is a tricky question because we consider hardware anything with atoms rather than bits. So the source for, a recipe for perfume looks extremely different than the source for a microcontroller. So that's why we can't have just like a really easy list of exactly what the source is, because each project is different. But if you think about anything that somebody needs to make a copy as the source, you are pretty much good to go. So it could be things like schematics or CAD files or code or even hand drawings. But these are all kind of the copyrightable things that are behind your hardware that produce your hardware, right? So anything that you can put a copyright on top of, that is most likely your source for the hardware. And then the hardware itself is like usually in traditional models a patentable thing. But what open source hardware does is we allow for sort of a different sort of option on the intellectual property landscape. So what does this look like in like real life? It looks like open schematics, open board files, open mechanical files, open chips, open recipes, open source software, of course, and in cases where you need assembly instructions for somebody to really truly have your hardware function, assembly instructions. And then if you've got all of that stuff, you can get an open source hardware certification through OSHWA. So the certification gives you a country code and a unique identifier number. And you can go to certificate.oshwa.org to see how that all works. But basically, you get to certify that, yes, OSHWA has looked through your source. We have verified that it's all there. We have validated that source as being open. The correct licenses are attached. And you can have a certification. And the way that the certification works is that is a trademarked logo. And so one of the things about open source hardware not being patented is it doesn't really fit into the intellectual property sort of mechanisms that are in place in most countries. However, by trademarking this logo, we feel that that might be a way where court system could understand that your intention was to open source it with this unique identifier number, and that the source was there. And so it kind of falls within a regular structure that our systems already understand. So in this instance, it's got some legal teeth. And the other thing a trademark does is it protects the consumer, right? So it tells the consumer that they can trust this particular product as being open source, and only the people that have created open source hardware with a certification can get this trademarked logo. This also creates a directory of all the open source hardware projects that have been certified. And this is important because you can view all the different projects that are open source hardware that have a certification. And you can also click through and find links to their source. Then we also have the open hardware facts. And those currently have a spot where you can quickly visually see the different licenses applied to the different parts of hardware. And then what we're really interested in is building this out. And so maybe someday it'll have like an attribution line on it, or maybe it'll have, where the derivatives, if you have a derivative, where the original is, or if you want to put recycling instructions on there or something like that. We're really interested to see how the community will kind of play with and build out this fact sheet. All right, so let's talk about a real world example. There's a really popular product out there called the Arduino microcontroller, and this is a piece of open source hardware. And what we have seen from this open source hardware is that it has created so many derivatives. There are a lot of derivatives around both form and function. So because this was open source hardware, people were able to say, you know what, this was great, and I really, got my use out of this particular microcontroller, but I need something that has a different feature on it. I need something that I can easily attach motors to, or Arduino's own derivative where they created a joystick, or it might be that they wanted a different form factor, right? So maybe they wanted it flexible or small or sewable. So there's all kinds of different derivatives that were made. And I don't think that the particular Arduino team would have potentially thought about a microcontroller that could be sewable, or they might not have thought about a particular feature set that one of their customers wanted. And as a business, they might have needed to stay focused on really what they were doing best and let all the derivatives kind of happen and cycle through and figure out which ones would be sustainable and which ones wouldn't be. So there's also lots of great things that can happen by, by pulling in different markets. Eventually, I think a lot of people probably went and found the original Arduino as well, from licensing their names on other people's derivatives, or from just having the IDE and the software being written in Arduino, allowing people to put their boards in the software was really important, so that people could always kind of look back and say, oh, right, this was a derivative of this product, and then I'm going to go get one of those too, and maybe get into the regular Arduino microcontroller, even though it came in from sewing and wearables. But our community, even though it was started in microcontrollers and electronics, has grown way beyond that. So we've got lots of crocheted pieces now. We have a car, we've got medical devices, we've got jewelry. There are lots of different examples of open hardware. Global Village Construction Set has open source tractors as an example. We've got open source space examples, open source laptops, open source fashion, open source bio, open source tools, open source hammocks, and open environmental initiatives. And of course, other useful applications. For example, if you need to make a wireless flamethrower for all your flamethrowing needs, here's an open source hardware project that is a wireless flamethrower. So what are the benefits of open sourcing? The benefits are that you get attribution, right, which is like a citation. And then you can create provenance from that attribution. So you can see the lineage of where a original project started and all the derivatives, or where a derivative happened, and get back to the original. You could even see derivatives of derivatives of derivatives. One of the other benefits, I think, is CERN's Open Hardware License Suite. So CERN, the place in Switzerland doing all kinds of amazing science, created a number of licenses with their legal team. And this is great because this means that their licenses have been vetted by a number of lawyers who are thinking about this kind of stuff all the time. And CERN is a very established organization. They're not going to go away tomorrow. So they are, upholding those licenses, creating new versions of those licenses, really understanding how it applies. So I think that's a huge benefit to have such a powerful, large scientific research base behind us in open source hardware. It encourages community and collaboration. So one of the huge benefits of creating open source hardware is that your community is allowed to get involved in building out the features it wants and building out different attributes of a piece of hardware that maybe you wouldn't have thought of. Maybe you're not interested in having a piece of hardware that has the particular, that tackles the particular problem set that somebody else is doing. It also creates prior art. So the certification database, for example, is a giant list of prior art with a date on it. And so in patent law, if something has prior art, then it is not able to be granted a patent on top of that. And then there's, of course, it incentivizes innovation. And so because of how I've been talking about these features that people are allowed to bring in, that companies are allowed to, understand what works in their community, a lot of the innovation will happen more frequently than, say, a closed source counterpart. We saw this in the 3D printing community. As soon as some of the 3D printing patents were up, the 3D printing community just exploded with innovation. There was tons of communities or companies all creating open source hardware 3D printers and competing with each other on a really open playing field. And so the innovation that was happening in those 3D printers went through the roof. There are limitations of open source, though. So hardware consists often of many parts, especially if you're trying to build something like an open source hardware car or an open source hardware computer. And so you don't always have control over all the parts, right? For example, you might be using some chips that aren't open hardware, and that is okay. We don't expect you to have every single thing open source hardware all the way down to your diodes and resistors. We're just not quite there in the world yet. But the intention that you put on the parts that you produce is what matters for open source hardware. So if you happen to use some closed source parts, as long as other people are able to source those parts, it can still be considered open source hardware as long as you put your intention on it that you want it to be open source hardware. All right, so pop quiz. Why do consumers buy things? I love to ask this question in all the lectures I give. Raise your hand if you purchase things based on how many patents they have. I have never had anyone raise their hand for that question. It's just not how consumers shop. So when you think about creating an open source hardware business or creating or monetizing open source hardware, the things that you have to worry about are actually not generally intellectual property from a customer standpoint. The things that you have to worry about are why customers buy things: features, colors, customer service, price, shipping, brand loyalty, quality, user experience, endorsements, availability, et cetera, et cetera, et cetera. There's lots of reasons that people buy things. But it turns out that patents aren't one of them. Now, I think the reverse is true, however. I do think that there is some altruism in consumers who want transparency in their things. And so they will buy something because it is open source, but they won't necessarily buy something because of the number of patents it has. All right, so what is the business model for open source hardware? To quote Chris Anderson from our 2012 Open Hardware Summit, he said, "The business model for open hardware is incredibly boring. You just sell your hardware for more than it cost you to buy," right? So if you bought all the parts, you mark it up, you put it on your website with a buy now button, and as long as you can ship that thing out, you've got a business model. And the number of businesses in open hardware are growing because I think people are understanding how to assess value. So assessing value is something that I got a really great example of the other day. I opened a toy robot, and in the back of the instruction manual to put the toy robot together was this grid. And mind you, this was not a piece of open source hardware. But in this spreadsheet, it had all kinds of different replacement parts. So you could buy replacement motors, the replacement plastics, you could buy, replacement brains to it. But what I thought was really interesting was the most expensive thing on this list was a $20 replacement instruction book. The paper thing itself was the most expensive. And that tells you what the most valuable thing is there. It's no longer the electronics. It is how to put them together in a specific way so that your robot will work. Again, not an open source example, but something I found absolutely fascinating from the perspective of consumers, what they'll buy, why they buy it, and where the value really is. All right, so we've got a number of businesses in open source hardware. These slides are, have a physical footprint, and so I could only fit so many of them on here. But I just wanted to highlight the successes that we've had in open source hardware businesses. So there are businesses that have been bought. There have been businesses that have been have built their own buildings. There have been businesses that exist in Manhattan where it's extremely expensive in the heart of New York City to have real estate. There are businesses that have gotten on the cover of Forbes 30 under 30 doing open source hardware. There are also lots of different nonprofits in open source hardware. So there's lots of different business models and structures that we can play in. There are emergency services as nonprofits in open source hardware. There's imagining reimagining manufacturing differently. There are health platforms and global village construction kits, all as nonprofits in open source hardware. There are also academics in open source hardware. So as you can see, this world is spreading far into many fields. We just finished our Open Hardware Creators in Academia Fellowship, and we had a number of fellows go through how the research of how to create open hardware in the academic system. So within the system of academia, what can we do? Where are the stoppers? What are the skills needed? How do we kind of navigate through the academic system to figure out how to create and adopt open source hardware? And then, of course, there's the reality of COVID-19. So one of the weird silver linings, if there's a silver lining with the pandemic, is that it really pushed forward this concept of open source hardware and its importance into the world. So it suddenly became very important to be able to just download some files off the internet and make your own face shield, or be able to share face masks with localized resources in different parts of the globe. So we needed like a lot more hardware produced than like in a very quick time than most things need to be produced in. And what we saw from that was not only this concept of sharing being perpetrated around the globe, but we also saw a lot of innovations happening, both that were certified as open source hardware, and things like this from Medtronic, this square that says our ventilator specifications, your ingenuity. So I want to be clear, Medtronic did not open source one of their ventilators as open source hardware by the book. But what they did do is they said, hey, you know what? We do still have the patent to this, right? They're very, traditional, patent heavy kind of industry. But they said, we are going to sort of release that patent and open some of these specifications that you can use, for this pandemic. So it's not like they said everything is free and open and whatnot, but it was a step in the right direction. Even places like Medtronic knew that it would be more efficient and more effective to have many, many minds at work. And so to get that done, they had to be more transparent with some of their source files. So that's a huge win for open hardware, even though it's not fully there. We always say that we're not trying to be a religion and that we're a welcoming community. And so whatever steps people can take to get there, we're there to meet you. And then we also have loads of different open hardware communities within our space. Many more than what are on the slide once again. But we are seeing open hardware communities pop up all the time in different fields, in different venues, in different avenues all around the globe. It's very heartening to see. We have a number of resources at OSHWA. We've got not only the open source hardware definition, we've got a certification, best practices, we've got community forums and a Discord, and we've got different checklists and FAQs that you can go through. And of course, we're here as well. If you have questions on how to open source your thing or how to get started, please reach out to us. And we have our next Open Hardware Summit coming up in Canada in 2024 in the springtime. You can see the URL is 2024.oshwa.org. You can go there and learn more about how to get involved. Thank you very much, and we hope that you create some open hardware soon.